Good afternoon, my name is Nick Renderly.
I'm Derek Gruden.
Vincent Mayberry.
I'm Jerry Klein. And so we are representing Draper, Aden Associates. Our mentors were Matt James and Lindsay Lally. We just want to start out by saying thanks for helping us out this semester. We really appreciate it. And so our objective was to design a residential development in Carroll County, Virginia, which you can see in the figure I provided is located in Southwest Virginia. And in the smaller image in the top right, you can see the outline of the site, and it is located adjacent to Interstate 77. So we were required to provide a minimum of 1,200 bedrooms using each building pad provided at least once. And our site is roughly 110 acres. It was zoned as a planned residential development, which basically means that it provides greater flexibility than the conventional zoning that you would have, allowing us to be a little bit more creative. And the access road for our site is Folsom Church Road, or Route 620. It is located off of exit 19, off of Interstate 77. For our existing utilities, consisted of water, which connects to the northwest section of the site, and a sanitary sewer, which is also runs along the road in the northwest section. It actually runs along the perimeter and down through the site to the southernmost section. And then we also had wetlands, 2 of them, which were smaller, run through the center of the site and were non-jurisdictional, which means that we were able to develop through them. And then a larger strip that was located in the northeast section, which was jurisdictional, meaning that we were not allowed to alter it in any way. And this is the first schematic design that we came up with. As you can see, there is a road that loops around the development. And as you enter, there's a clubhouse up there in the northern section. And then we have 2 main clusters of multifamily residential units, which are in layman's terms apartments. And then we have ample amount of parking areas around these. And one of the benefits of this layout was that there's a large amount of green space, but it wasn't very cost effective, so we ended up going with the second schematic design. And this one, as you can see, the road starts out in the northwest section of the site, connects to the existing road that was provided. And like the first one, the clubhouse is located right at the entrance right when you come in. But different, it had the apartment buildings that are lining the 2-lane road. And in between the road and the buildings were the parking lot was provided. And then we also had an ample amount of green space. And the reason we chose this site is because it was a lot more cost effective and less space intensive than that first.
All right, so this is a layout of our road design for our site. As you can see, it started in the northwest corner of the site and then ran along the western side of the site into the south part where it ended in cul-de-sac at the bottom. It's a single roadway, and being a residential development, we used a 25-mile-an-hour design speed, and we had no stopping sight distance issues along the road. The road was graded at a constant 0.69% sloping down to the south, and the assembly we used was 2 13-feet lanes crowned at the center at a 2% slope, each with a 2-foot gutter pan, also at a 2% slope. And the western side of the road has a 5-foot sidewalk, which is also at a 2% slope. So this is the layout for our final grading of the site. Generally, the grade of the site was graded so that it was sloped down with the road towards the south of the site. And the blue arrows on the layout shown there is the general grading of how we graded the parking lots. The way we wanted to convey the stormwater was to either bring the water back towards the road or bring it to a location in the parking lots where we could have a stormwater inlet in order to convey the water. The offsets were used outside of the buildings to provide the required 10 feet of 5% slopes away from the buildings. We tied into the existing surface outside of the buildings at a 3-to-1 slope, which was our maximum grassed area slope. The minimum grassed area slope was 0.65%, and our maximum paved area slope was 5% at one of the entrances of the parking lots. And the minimum paved area slope was 0.61%, so we stayed within that 0.5% to 5% range. Since we weren't allowed to tie into the existing surface outside the boundary of our site, we needed to place a few retaining walls along the, mostly on the southwest of the site there, showing us that dark black line.
All right, for stormwater management, we used the TR55 method. We decided to split our site into 3 separate watersheds and find pre and post development flows for each of those 3. Using that, we found a large increase in all 3 and bringing us to a total storage needed of just under 213,000 cubic feet volume to return those post values back to pre-development flow. And we split that requirement up into the 3 different locations and had 3 different volume of storage on our site in each location, which I'll show you in a moment. Our inlet placement from there, we decided we needed to try to lower costs, so we only kept them at every 300 feet along the road and at low points where necessary in the parking lots. We decided in order to keep our pipe sizings low due to the large size of the site that we would have to have a number of storm sewer networks so that we wouldn't have one large network consisting of a huge pipe by the time that it got to the bottom. And so we had separate networks and 28 inlets, and most of our pipes ended up being 15-inch pipe since we did split it up. Give it the next slide. Just under 3,000 linear feet of it was 15-inch reinforced concrete pipe, and then it ranged up from 18-inch to 24-inch from there, but not a large linear footage required of that. As I said before, we have 3 different locations. If you notice in the middle, there's a retention pond there, retention pond in the very center of the site, and then we went with underground detention for our last area. We were able to keep all of our velocities in between the 2 and 10%, or 10 feet per second requirement. And so Jerry's going to talk about sanitary and ENS.
Okay, so first for our water system, the main thing you want to consider when you have to design a water system is the fire flow. That's essentially a function of the building material and the floor area of your planned buildings. We had everything ranging from 2,000 to 5,000 gallons per minute, so we figured that was good enough for the buildings that we had to provide for. We had valves, butterfly valve is shown. That kind of segments the system. We had a lot of air release valves at high points. This was a lot in the northern part of the site. And then we also had blow-off valves, a lot of which were fire hydrants. And those are kind of to drain a section and to provide the fire flow needed for buildings. We maintain separations for our system, essentially having our water system run along the road alignment. So that, in addition to the sanitary sewer, we had to keep them separated. When they would intersect, we would have the 18-inch vertical separation. And we chose to use a dead-end system for the water system because, as you saw, we have essentially a single strip road for our water system to follow. We didn't think it was really necessary to have a loop system when it could just follow the road alignment and work effectively in that way. So for our sanitary sewer system, for the flow design, we considered the VDH standards, peak factors. We used a peak factor of 4 just to facilitate the amount or the volume of wastewater that we would need to transfer. And so we had to consider manholes for the system as well. You essentially want to have a manhole at all changes in grade, size, alignment, as well as all intersections and junctions of pipes. So you also want to have 400 or 500 foot sections, which we also included. That's 400 feet for 15-inch diameter pipe, and then for up to 30-inch diameter pipe, you want to have 500 foot sections. So this is the phase 1 ENSC plan. You can see that a lot of it is silt fencing and then diversion dikes as well. It's all of the lines around the outside border of the site. This is essentially to to protect against erosion, and the diversion dikes especially to protect high vulnerability areas. And they lead to the sediment traps and sediment basin. We have a sediment basin in the southern part of the site, and that's for the majority of the drainage area. And so for phase 2, we have a lot of similar things. We phase out a few of the different methods. We keep a lot of the silt fencing. We have a lot of inlet protection along the road and in the parking lots. And that's to protect the many inlets that we have. And then down the, southern part of the site, the southeast part of the site, There's a lot of topsoil and seeding. This is to ensure green space requirements as well as to protect against erosion following the beginning of construction. And so the last thing we want to talk about is our cost estimate for materials is about a little less than $11 million for the site. And we think that it would be, to effectively reduce that, would be to balance cut and fill, because we had a very site with a lot of slopes, and we wanted to flatten it almost entirely, which is a very difficult process to do with minimizing cut and fill. So, any questions?
How much dirt did you need to bring in to make that grading work?
You guys remember a figure for that?
I think it was 134,000 cubic yards.
Okay.
When you guys were going through, did you have anything that you thought of to help do that balance the cut and fill?
Yeah, we talked about, if we had time to redo the whole road corridor, we probably would have done a lot of terracing with the road as opposed to just doing a straight slope, because the way it looked on the profile, it actually balanced it out, but when we actually do the grading of the whole site, it didn't turn out that way.
Can you explain the purpose of your blow-off valves again?
Blow-off valves are essentially to drain a section of the water system in case you need to perform any maintenance. So, and then you want to have them at terminal ends, so we have one at the, essentially in the cul-de-sac to kind of end the water system.
Other questions for these guys? Michelle?